All right, let's talk about the solution to example 3.2. So the idea here is that we are looking at a solution containing 15% A by mass. So we're dealing with a mass fraction of A and 20% by mole of B, which means we have a mole fraction of B. So the first problem asks you to calculate the mass of A in 25 kilograms of solution. So this is really a units problem. If we have 175 kilograms of solution, we need to multiply that by something that has kilograms of solution in the bottom and kilograms of A in the top in order to get the mass of A. All right. Now, what do we know that has units of kilograms of A per kilograms of solution? And the solution here would be the total, right? So that is the definition of a mass fraction. So 0.15 over 1 is the mass fraction, right? That's kilograms of A per kilogram of solution. So if we multiply the 0.15 times this 175 kilograms, we see that 26 kilograms of A, are in the solution, right? That's 15% of this, right? And that's the definition of mass fraction. And we're not doing this next one. This is from a previous year. So we're going to skip on down to do number 2 for you this year, which is calculating the molar flow rate of B in the stream that's flowing at 1,000 moles per minute. So if we take the 1,000 moles in the stream per minute, in order to figure out what the molar flow rate of B is, we can keep the minutes, right? Because that would be in a flow rate. Doesn't matter if it's minutes or seconds. As long as there's a time in the denominator, that's a rate, right? And we want to find something, let's put an equal sign here, that is going to give us moles of B per minute. That's a molar flow rate of B, right? So basically what we need to do is we don't really care about the minutes, but we've got to get rid of the moles in the stream. And we want something with moles of B in the top, right? Well, this right here, moles of B per moles of stream, is B over the total. So that is the molar fraction, the mole fraction. So if we go back up to the top, we have, where is it? There it is, the molar fraction of B as 0.20. So that's the number we're going to put in here, 0.20, right? So if we multiply 1,000 by 0.2, we will find that 200 moles of B per minute are flowing in that stream. So these first two problems are really defining what mass and mole fraction are. All right. The last one's a little bit different, but we can use units again to kind of help us out here. If we have 28 kilomoles of B per second flowing in a stream, and we want the total solution flow rate. So we want kilomoles of solution per second. That's what we want, right? So again, we don't have to do anything with the seconds, but we got to do something about the fact that this is moles of B and we want kilomoles of solution. So if we want kilomoles of B to go away, it has to be in the bottom. If we want kilomoles of solution, it's got to be in the top. And I apologize, this is going to get a little messy here. Okay, so we know we have 0.2 moles of B per moles of solution. So the 0.2 is going to go on the bottom this time. And remember that even though this is kilomoles, it doesn't matter, right? Because we can do this in terms of moles or we can do this in terms of kilomoles because a mass fraction is a percent. So it doesn't necessarily matter. All right, so if we do that, what we're going to find is we're going to have 140 kilomoles of solution per second. Now, does that make sense? This is bigger than the 28, right? Well, yeah, that does make sense because this is only a fraction of the total stream. This is only 20% of the total stream. That's what this number is telling us. So if we have the full stream, that means we're going to have 140 kilomoles per second. All right, so that's example 3.2. So as you can see, it's really about figuring out units. You need to understand that mass and mole fractions have units of the mass or the mole of a substance divided by the total amount. And that's the critical component to dealing with mass and mole fractions.